Hello sir, my name is Masud Rana, roll number 34900323023, third year 5th semester. Today I will be presenting a topic from digital communication, pulse code modulation or PCM. So let's begin. Concept of PCM. Information is transmitted in the form of code words. This means PCM is a method of transmitting information in the form of code words, in other words. The message signal is represented as sequence of binary digits, for example 101 101, before being sent through a communication channel. Next, block diagram. The process begins with the message signal passing through a low-pass filter which removes high-frequency components. The filtered signal then goes to the sampling stage, producing a flat-top pulse amplitude modulated signal. This PM signal enters the quantizer, which round off its sample to the nearest quantization level, giving us quantized PM. Next, the encoder. The quantized samples are then fed into the encoder, an analog to digital converter, which converts them into binary form. Next, the digital data is passed through a parallel to serial converter, so it can be sent through the channel. At the receiver, a serial to parallel converter converts the data back into parallel form. The decoder then changes the binary data into quantized PM, and finally a low-pass reconstruction filter restores the original message signal. Next, waveform representation. Let's take xt as the message signal and ct as sampling pulse trend. Multiplying them, xt into ct produces the flat top PM signal. This is after quantization, then quantized and encoded into binary form for transmission. Next, PCM receiver with noise. If the received PCM signal has noise, the regeneration circuit removes the noise and restores the clean PCM. Then clean PCM is then converted to parallel form, decoded back to quantized PM, and finally low pass filtered to obtain the reconstructed signal. Advantage of PCM: very high noise immunity. It is possible to restore the PCM signal due to its digital nature. It is possible to use various coding techniques so that only the desired person can decode the received signal. Integration with the other form of digital data is possible. Disadvantage of PCM: the encoding, decoding and quantizing circuitry of PCM is complex. PCM requires a large bandwidth as compared to the other system. Applications of PCM: telephone and voice transmission, audio and video recording, etc. Now we will see the quantization process. This means rounding off, for example, rounding 5.19 to 5.2. The quantization process is about approximating your signal. Here Q1, Q2, Q3, etc. are the quantization levels, and del 0, del 1, del 2, etc. are the ranges. This means that for all signals within del 1 range, we will call them Q0. Let's understand Q0. The midpoint of del 1 is Q0. In short, all signals that come within del 1 are rounded off to Q0. Similarly, all signals in del 2 are rounded off Q1. Next, quantization error. This is the difference between XQT quantized signal and XT original signal. If the number of quantization level is Q and the maximum signal amplitude is XM, the step size is del equal to 2XM by Q. Example, how many bits are needed to represent 8 voltage level? We know Q equal to 2 to the power n, for Q equal to 8, 8 equal to 2 to the power 3, then n equal to 3 bits. We can also do this using the step size process. Next, signal to quantization noise power ratio, SQNR or SNR. This is divided into two types, uniform and non-uniform. Uniform is further divided into mid-rise and mid-trade. The difference between uniform and non-uniform is then in uniform the step size is constant, while in non-uniform step size is not constant and depends on the amplitude of the input signal. SQNR equal to signal power by quantization noise power. SQNR equal to P by del by 12, del equal to 2xm by q, then del square equal to 4x square m by q square. SQNR equal to P by 4x square m by q square 12 equal to 3pq square by x square m. SQNR equal to 3p to the power 2v by x square m. Thank you.